Hi, this is meteorologist Steve Pelletieri, and I am the Weatherman. Welcome to our latest podcast, and this time I'm going to continue to talk about a topic that's near and dear to my heart, and I'm talking about the second part of our aviation weather discussion. Now, there's so much information here, I had to break it up into two parts, and this is part two for aviation weather. And additionally, we'll talk about the summer so far and the 24-hour sun above the Arctic Circle. Now, there's a website that I look at a lot. That's going back to aviation now, and it's called FlightAware.com. And at FlightAware.com, they track aviation flights from all over the world on an instantaneous basis. You can see how having advanced radar and working with meteorological centers allows pilots to go into gaps between thunderstorms or heavy rains or turbulent areas. These pilots not only work with their meteorological centers, but also with the US FAA and the NOAA-sponsored major scheduling centers called the Center for Weather Service. That's part of a system of command center in the Washington, D.C. metro area. Now, I was associated with a meteorologist called Bud Norman Lacey. He was one of the first certified consultant meteorologists back in the 1960s, and he had a lot of experience working with the Army Air Force during World War II in Egypt and in southern Italy. So Bud, of course, no longer with us now, but gave us a lot of great information back in the 1990s. And one of my students and former employee is also a CCUmer. He works at the center as well, and that's John Yoon. And John has been working there so far for the last several years, and we're going to be talking about him and talking to him over the next several broadcasts that we have here. Now, this center where Bud worked and where John works, they are instrumental in opening up and closing down airways, airports, and weather situations at major area airports in the U.S. And they're coordinating with all other national command centers across the world, like in Frankfurt, in Paris, and also in Moscow and Hong Kong, and in Mumbai, where there are major centers for transportation. Now, the whole key to aviation weather improving over the last 10 to 15 years is stronger computing power, along with improved satellite and radar technology as well. Now, I've always mentioned that sophisticated science and scientific weather models have given our aviation interests more detailed understanding of concepts and conditions. Now, this means that aviation interests can better plan their operations before flights and by canceling flights early to avoid stranding passengers at hub airports. As I mentioned earlier in the first part of this discussion, this new information can help aviation interests better navigate around storms and avoid turbulence. Now, this is no small matter. Weather accounted for 36% of all airline delays in recent years, but that's down from about 50% at the turn of the century in 2000. So a lot has been and continues to be done as far as monitoring and working with the weather situation across not only North America, but the world. Aviation-wise, the 7-day forecast today in 2020-2021 is about as accurate as the 3-day forecast was 10 years ago. So in 2021, it's about as accurate as the 3-day forecast was 10 years ago, the 10-day forecast. That's pretty cool. Meteorologists use these aviation weather centers, and they provide detailed weather reports to the whole airline and aviation industry. That includes conference calls, calls with the FAA, calls with Central Command that I mentioned earlier in D.C., along with storm and rain predictions. But not only here in the U.S., or North America, but they also deal with global forecasts every 6 hours that are used by airlines and aviation interests across the world. I guess the recent pandemic, which has closed down a lot of the aviation or at least flights across the globe over the last 6 months, has given these centers the ability to regroup, relook at the whole situation, and improve. So I think things are going to get a lot better as far as dealing with aviation and weather over the next several years, of course. Dealing with aviation forecasts is no easy task. Through about 60,000 flights in America or North America every day, and about 8,000 aircraft in the air at any one given time, weather is one of the variables that disrupts operations the most. It's weather. Can you imagine 60,000 flights every day, 8,000 aircraft in the air at any given time? And if the weather is bad, believe me, they don't let you take off, they don't let you land because they don't want you being into those very bad weather situations. In other words, a storm over the northeast corner of Pennsylvania, and this is where much of the air traffic comes from for New York and the big three airports, Newark, LaGuardia, and JFK, can cause widespread delays all the way to the West Coast. Can't take off if you can't land. And turbulence also poses a particular challenge because it can't be seen by radar or satellites. Well, there are indications you can see with some of the other enhanced indicators on satellites. You can see some turbulence, but it's more like from pilot reports. Pilots know to anticipate turbulence because of the drastic wind or temperature change. You can't believe how the temperature changing at, say, 35,000 feet, temperature changing 5 degrees can cause a tremendous amount of turbulence. Why? Because air is mass. Even though you can't see it, you can't feel it, we breathe it, but it does have a specific amount of mass. And the colder that air is, there's more mass because the molecules can stay more packed together. So when you go from a less dense air, a warmer temperature, to a more dense air, which is a colder temperature, even aloft, even by several degrees, it means that you go into more mass, which causes differences in the amount of lift on wings, which causes turbulence. All of a sudden you're sitting there and all of a sudden the airplane rises or sits, rises or falls. Those type of things are called turbulence, and that's because of basically just temperature changes. Of course, you also have turbulence because of wind shear and wind change directions aloft, along with those temperatures. And when you have the combination of the two, it's very uncomfortable being a passenger in an airline flight in that situation. Talking about turbulence, an average of 36 people have been injured as a result of some type of turbulence each and every year since 2000. That's not too bad considering the amount of people that have been flying. But it's getting less and less because we're able to find those atmospheric or meteorological situations that result in turbulence, along with better reporting instances. Now, another thing is not getting the weather right. Well, it's just half the story. Obviously, planes are also delayed by congested airspace. For example, in New York metro area, there are literally, if you add off the tonnage of what the weight of the airplanes are that are in the air, there are literally tons of airplanes coming into Newark, LaGuardia, JFK, Stewart Field in Newburgh, New York, and then even to smaller places like Islip, White Plains, Allentown, and even Atlantic City. That happens everywhere all across the country, especially in the more populated areas of the East and the West Coast. Well, all this information that we have, things still go wrong. Weather-wise, for example, this massive effort to identify bad weather could target a specific area like, let's say, Denver. Then the storm doesn't materialize, in which case there were tons of delays and diversions because of the expected bad weather in Denver that really didn't materialize. The bad weather forecasted doesn't happen, yet diversions happen. But that's getting less and less likely. It's less and less of an occurrence that we are seeing at this point. So forecasting weather is a very unforgiving practice. And when you miss the mark, a lot of people come barking at you. Oh, those weathermen always get it wrong. This has been bad. Blah, blah, my goodness, I have to go there. You don't even think about your safety. You think it's just normally like getting into a car, traveling on a highway. Even though on a highway you're going 70 miles per hour in what you think is your living room, but it's really not, you get this false sense of security. False sense of security in airplanes. You should be able to do it right. But everybody is working to keep those flights safe. And even though you're inconvenienced, believe me, there are a lot of people working on inconveniencing you so that you are safe and alive and that things go well. So even if the bad weather doesn't happen, diversions do happen. I'm seeing that less and less. It's an unforgiving practice, forecasting weather. And when you miss a mark, a lot of people come barking, as I said. Which brings me back to my original statement early in this podcast about working with pilots and aviation. As I was fresh out of college, I had enthusiasm for aviation. Not a mystery that I wanted to be a pilot. I've kind of been indicating that time and time again as I go through here. But the situation did not present itself. So here I am talking to all these folks about weather, and I'm not actually going to fly or being a pilot. So it's a tough situation forecasting aviation weather. But as I mentioned, in the future, I will be offering a podcast on private pilot aviation weather. We're just going to go right through it, even almost like some coursework. I was talking to Dr. Ed about it, and he says, hey, there's a lot of information, a lot of people out there who want to know more and more about weather. It's a great part, or actually an important part of the written exam for private pilots, and it's something that we're going to be covering in a podcast soon. So there's so much information that I'm going to be giving you. A lot of times you just have to sort of like just lay back, maybe listen to it 1 or 2, 3 times, and you can get the whole situation of what's actually going on as far as weather is concerned, with aviation, with the just day-to-day weather situation, with our lives, this, that, and the other. Really very interesting stuff. So talking about aviation weather really deals with a mini course. It deals with aviation, but a lot of it is just plain weather theory and practice. And with that in mind, a lot of the information is given will be quite informative, so you will not be disappointed. Even if you don't even have any, you don't want to fly. I'm not going to be a pilot. But maybe you want to know what they think of. It's really good to listen in. You're going to get some great information. Now, like I have been constantly mentioning, the forecasting process is constantly evolving. You think they just go out there and look at their crystal ball and they say, oh, it's going to be this, that, and the other. No, they're using models. They're using weather models. Very intense, very complex, and very almost sometimes unforgiving weather models to forecast not only what's going to be tomorrow. They start with steps in forecasting. They step at 3 hours, 6. Actually, they start with 1 minute, but that's extrapolated all the way out to 3 hours. Then 6, 12, 18, all the way up to 7, 8, 9 days in advance. And they do that 4 times a day right now. And some of the computer models and computer, industry that they're having, the computer machines themselves are getting stronger and stronger so that they'll be able to do this 8 times a day. But you have to have good data to go in. Bad data in, bad data out. Good data in, good data out. And that's our problem right now. We'll talk about that in another time. But that is one of the things that causes weather models maybe not to be as accurate as they could be. But when you start talking about computers, my goodness, the strength, the complexity is absolutely unbelievable. The National Weather Service uses 2 supercomputers. One is in Reston, Virginia, known as TIDE. That's because that's near the tidelands of Virginia. And the other backup is close by facility that's over 200, what they say 213, what we call teraflops, or 213 trillion calculations every second. 213 trillion calculations every second. So let's take a look what a million is. A million is 10 100,000s. A billion is 1,000 million. A trillion is 1,000 billion. We're talking about 213 trillion. 213,000 billion calculations every second. That's amazing. 213 trillion calculations every second. It's been a recent upgrade, and not only that, but speeds are getting faster. Can you imagine getting faster than what I just mentioned to you? It's really amazing. Most likely in the next year or two, it will be increased to 200 trillion. Say again, 200 trillion calculations a second in order to forecast weather. The problem is when you're not forecasting weather, what you're doing is you're forecasting parameters for a specific grid. In other words, you take the whole world and you place it into this like grid points, into little squares. And each individual intersection of each of those squares is an intersection that's predicted for. But it's not only for the surface, but it goes all the way up into the higher ends of the atmosphere. So you're dealing with a multi-dimensional type of situation. We're also expecting that new satellites, along with increased, more accurate radar observations and new technology, who knows what's going to happen in the future, not only for aviation, but for general weather services as well, right up to 2030. And who knows? Who really knows what's going to actually happen with some of that information that's coming in? So I expect the improvement to be spectacular. No, I expect it to be super spectacular over the next 10 years. You're really going to enjoy it. But you really have to have a good understanding of what it is and a good comprehension and an appreciation of what's happening with weather forecasting and weather modeling. All things considered, weather analysis and forecasting for both aviation and the public will constantly improve through the upcoming years. There is no doubt in that. No doubt whatsoever. We're not stopping. We're going forward. So we're coming to the end of our discussion on aviation and meteorology. There's so much to talk about. It's such a diverse and complicated topic. We talk about the private pilot, the commercial pilot, the airline, the military, everything. There's just so much more to talk about. I think what we're going to do is we're going to do a podcast on aviation weather for the written exam. That may not be important to you on this one. You can skip that one, but I'll always throw in some recent weather information, and it's something that you just might want to tune in for. So we really didn't go into the military that much, but suffice to say that they have their own weather departments, especially the Navy. The U.S. Navy deals with conditions all over the globe, and they have to be on top of everything. They train their meteorologists their own way, making sure that they understand the weather conditions all across the globe. If you took most of the navies of the world and put them together, 5, 10 of the navies of different countries, they still would be less than the U.S. Navy because they're all over the globe, part of the Cold War, the situation that developed after World War II. And of course, the Air Force is dealing with these missions. They go on from the center of the North American continent all the way to the far reaches of the globe. They take off from Montana, they go to the Mideast, or they go to the Southeast, and they end up coming back because they use the refueling aloft. And they're able to take care of those missions. So they have to know global weather on a constant basis. So they have to know the winds aloft, how much fuel burn they're going to have, the temperatures aloft, and where you should schedule an in-flight refueling because of the type of crazy weather that could be occurring, both back and forth to a mission for the Air Force. So again, this discussion deals with aviation meteorology in summertime. If you're a student pilot, you can expect some of your best weather training and flying somewhere between, let's say, 7 a.m. to about 10 a.m. Because at that time, although the visibility may be a bit lower because of haze and winds, there's usually light conditions, and generally still in low-level flight weather is at its best in the morning hours. However, in the afternoon and the evening, the air is hot and, let's say, unstable. As you fly, the lift under your wings is not as great because of less density of the air, less mass. Remember I was telling you that when air is hot, there's less molecules under the wing, less to force you, less to give you some lift under those wings. And again, in the afternoon, we have to deal with thunderstorms. Thunderstorms can cause tremendously changeable conditions in just short areas, short periods of time. And in our previous podcast, between 30 and 45 minutes, these thunderstorms form. So you can take off, think nothing's going on, and then all of a sudden these thunderstorms form in a short period of time, and they move across an area, then die out just as quickly. So forecasting these events is getting better and better all the time. But for aviation interests, especially the student pilot and the airline traveler, your best weather is in the morning. I tell my sons and family all that I know. And if you're going to fly in the morning as early as you can, especially in the summertime. The airplanes are probably there and have come in overnight and are not dealing with any thunderstorms or any delays thereof. And the net effect of everything is timely. I've seen many, many times that the mid to late afternoon, all across the nation, extensive delays occur because of thunderstorms, especially at hub airports across the nation. So again, the best time to fly is in the morning if you're going to get home. And if I'm on a one-day trip for business, when I come in late at night, afternoon delays can make problems, even cancellations. So, best thing, get a hotel and take the first flight out. You will not be sorry. Leave early in the morning, stay overnight, take the first flight out, and you'll be in great shape. Early morning is a special experience. I know you have to get up. It's sometimes not fun. Aviation weather in the wintertime is a turkey shoot. You can have a big blizzard that closes things down, strong winds, heavy turbulence, low ceilings, low visibility, not to mention snow, sleet, rain, and ice. In the springtime, especially in the Midwest, comes the weather season of severe weather and occurs mainly in the afternoon and early evening. Avoid those times if you plan to fly. I know no one likes getting up at 4 a.m. to go on a flight, but guess what? You'll get there because the flight will most likely not be delayed and there will be no or few weather delays. Similar situations are in the autumn, but then again, we're also dealing with the possibility of tropical systems, depending on where you're going. All in all, aviation weather is important to the private, commercial, and airline pilot and to us as passengers and travelers. The weather can make or break a trip. Your best time to fly is in the morning, always as early as possible. First flight out, last flight in, or early morning next day. As a student pilot, your best training weather is in the morning for beginners, but you will need the experience of all-day weather so you can gradually work up to that with time. Okay, we've talked about a lot about aviation weather, and there's so much more to talk about. However, I promised that we're getting into the late portion of the month of July and here in 2020 and talk about Arctic sun. We've gotten that to you, giving you a little bit of information on how the sun rises or stays sort of like circular in the sky. During the wintertime, the Earth, the atmosphere is pointing away, so therefore the sun is circling below us. That means 24 hours of darkness, temperature falls, so on and so forth. As we get into the latter portion of July and early August, we're dealing with the dog days of summer. And that, of course, deals with still some hazy sunshine, some hot, humid weather, but maybe a sea breeze. But along the coast of the eastern portion of the United States, the temperatures have been up some 5 to 7 degrees above what they normally are this time of year. So even at the shore, it looks like it's going to be a hot one. Average temperatures in the month of July are about 5 to 7 degrees above normal by the end of the month. And this is after a very cool spring, a very hot summer. So we're getting into that type of weather pattern, at least as we go into the early August. But we'll talk about that as we get to the next podcast. Once again, getting close to the end of the discussion here. Information is a lot. Maybe I should break into another type of discussion as we get into the latter portion of July and early August. We're going to be back very soon talking about some new weather situations. I am meteorologist Steve Pelletieri, and I am the Weatherman. Thanks so much for listening, and we'll talk to you real soon.